Okay, what we're going to look at here is this really irritating little circuit. I've got a 9-volt battery powering it up. I have got a little relay switch which has been switched on and off, and connected to that relay switch I've got this irritating buzzer. You can see that I've also got a little LED over here which is pulsing away, and what I need to show you is how the circuit is working first of all. Well, I've got a resistor over here. Let's just go over there. There's one resistor is connected into the circuit. You'll see that I've got another resistor over here, but that's not being connected into the circuit just yet. I want to show you what happens when I do connect that. The resistor over here is resisting the current flow flowing through here and into my capacitor over there. Okay, now the way this thing works is when the capacitor is fully charged, it suddenly discharges, sending a pulse to the 555 timer circuit, which then is able to pulse through to this little light bulb and also to my little relay switch over here, which makes everything go beep. Right, what I need to show is the idea of the current flow. If I had less resistance in the circuit, my little capacitor would be able to charge up more quickly, and then it would be able to discharge more quickly, which means that this light would go flashing a whole lot faster, and so that beep would also be a whole lot faster. What must I do in order to increase the current flow? Obviously, current is determined by the resistance in the circuit. If I've got less resistance in the circuit, then I'm going to be able to have more current flow. If I've got more current flow, as I said, this will be able to charge up and discharge more quickly. Now, what I've got here is I've just got that single resistor. If I had to add another resistor to this, your mind is probably saying, well, there'd be two resistors in the circuit, therefore I would have less current flow going to my capacitor. Okay? But that all depends on whether you can connect them in series or parallel. I'm just going to demonstrate when I connect this resistor in a parallel fashion. When I connect it in parallel, you're going to see that the current flow actually increases. And the lesson that I need to do with you is to show you why it is that I have more current flow when I've got resistors connected in parallel. In other words, I'm actually decreasing my resistance when I've got two resistors in parallel. I'm going to try to connect this, okay, just by touching this leg to that leg over there. You can see I'm touching that leg. What have I done? I've connected those two in parallel. In other words, I connected the two. You can see the two resistors in parallel. And you can see that my circuit is working its butt off, going a whole lot faster. Why? Because there's less resistance, which means that there's more current flow, which means that my capacitor is able to charge up and discharge more quickly, making everything work a whole lot more quickly. One resistor, two resistors in parallel is decreasing the resistance and increasing the current flow. Parallel, increasing the current flow. There is less resistance when there are two resistors in parallel than just having the one resistor.